What is the approach? And there is a cost-effective alternative. Okay, so again, it's getting late, so I'm going to save the intense detail. But in cognitive science, there's a system called ACT-R, okay? And the way it works is it's a cognitive model in a similar way, but it is designed like the human brain. So it uses a parallel processor, which mathematical units representing brain cells are little simple programs that are designed to adapt based on feedback, based on behavior. And they are grouped into segments responsible for different components the same way that we see in the brain. So you have a whole cluster representing episodic memory. And you run it millions of times and it starts to learn how it should behave because in its program it adapts to feedback. You have a similar cluster for all the different other parts that are relevant. You don't have to do like the motor behavior because we're just talking about a car driving, but all the parts that are relevant. And ACT-R is basically a framework that it's huge in cognitive science, and the whole idea is that instead of just designing it as a cool experiment, they designed it with a framework of a programming language that you can use it and you can apply it. So Distract-R is something that Salvucci, a scientist, did, which applies this to the distraction situation, the human multitasking situation. Now, the interesting part about Distract-R is part of it, to get over this hill of having to remodel your cognitive architecture every time you have a new interface, they designed their own prototyping systems, so systems like Acture and things like that. This is a very simple version right now because it's just an experiment and it hasn't been implemented yet. But you can use the system to design buttons. So if you have a cell phone, you can make a similar version of your prototype in the Distract-R model, and then you press power button and you run like 1 million trials of cognitive architectures driving your car down the street for 2 hours. So in 2 days of computer processing, you have 1 million drivers driving your car for 2 hours and testing your interface. This is unbelievably powerful, and it might put usability testers out of a job. But we're a couple like 10, 20 years away from even that being impossible because there's nothing that can replace the real thing. But when it's 1% of the cost and 1% of the time, it's something we need to think about most definitely. Now, the early data looks good, so this should be scary to some of you. But the idea is the white bars represent, we'll save the details about the tasks, but the white bars represent cognitive modeling the manual way as I talked about earlier. The black bars represent the Distract-R model, and the gray bars represent real human data. And so each of these different things represents different interfaces and the measurements of how distracting these interfaces would be. So we beat out the cognitive models, and we're approaching human data, except for this one for some reason. But it's bizarre that you could send a prototype of your interface into a cognitive architecture pseudo brain and run 1 million hours of testing and get data that even closely resembles humanity. It just boggles the mind. But anyway, so that's interesting, and that tackles one side of the problem in terms of usability, which is optimizing our interfaces. But the other side of the problem is, of course, optimizing the car's interface. Because when distractions are a problem, we can also improve the car to handle it. And there's a specific example I want to bring up, and I've only got one, so almost done here. But I've only got one example, but the specific example I want to bring up is it's really important because in terms of being a usability specialist, in terms of being a designer, the thing that it ties to is user experience. And it was a secondary finding in the study, which they just wrote in their extra notes. But when I read it, it was the most salient part of the study. So the idea is that a test was performed, and basically so imagine you're driving in your car, and the car in front of you hits the brakes. And as it hits the brakes, a little alarm goes off in your car, radio signal from the car in front of you to let you know that the car in front of you is slowing down. So if you were distracted, this alarm would bring your attention back to the road. So if you're driving along like the dude was, and you're reaching for your cigarette, which you dropped between your legs, but then someone was braking in front of you, it would be like, and you would look up and you'd realize the car's there and you would hit the brakes. And so when they did these experiments, it actually showed a significant improvement, so it worked. But the secret hidden finding that I was referring to was that somewhere off in the minute corner of their extra notes, they mentioned that it was interesting that subjects found the graded warnings as opposed to a loud alarm. So the more they hit the brakes, the louder the alarm is. and tactile response, where the steering wheel vibrates as opposed to making a screaming noise, or less annoying, as they call it, less annoying, right? But to me that jumps out, less annoying jumps out user experience, in the sense that we're talking about safety here, yet like while accommodating safety, we can still maintain the user experience. And I would argue even make it better, because these things, these luxury items like fading the lights on and off in your car, these things improve the user experience. You feel like you're in this luxury intelligent machine that is helping you. And that is the whole user experience. It's helping you. It's shaking because it wants to tell you, hey, listen up, forget about your cigarette because you might die, right? This is a helpful comment. And so I think the conclusion here, as I was just saying, is that, to recap what we were doing here, distractions steal attentional resources, as Karim was talking about, and that in-car user interfaces can exacerbate, can be these distractions, and that scientists are looking at paradigms of how we can test and measure distraction. But as usability specialists, because we're not scientists, so hey, it's all interesting, it's cool to sit around and discuss the science, but where does it affect us is that this science is going to become very important, and that if we were all working for a car company, we can't just ignore safety. And I think the current model here is that you're looking at, imagine a car company, that's a good example. So imagine you have a guy, and he's working on safety, and you're working on a car, and you're the usability guy, and you're hanging out and you have a conversation with the safety guy, and oh, you're making a cool brake alarm? That's cool, that's interesting. And you kind of see the overlap there, and you work a little bit together, and then you both deliver your final products, and he's got this loud, annoying alarm, and you've got meticulous user research trying to build this amazing dashboard for your car, and the people sit in the car and they're like, oh, this is fantastic, what a nice drive. And then every time someone hits the brakes, it's like, every time you drive down the road, it kills the whole thing. So the idea is that you need to take a look at the whole thing in terms of user experience, that when you approach a problem like this in safety, user experience is the aspect of absorbing other concepts like safety and making sure every front of the interface is looked at from a user point of view. Not just the quote-unquote, make sure the buttons are in the right place and the steering wheel is aligned usability testing, but making sure that everything gets tested. And that safety, as important as it is, and that if you went to a boardroom full of suits and said, okay, well, safety is more important than usability because safety can kill people, it doesn't have to be mutually exclusive. We can be safe and we can maintain the user experience. And that is it.